Your aim of experiment is to prepare a cylindrical job of multiple lathe operation. Raw material MS round bar, MS for mild steel. Okay, having diameter 25 millimeter and length 28 mm. So these are the tools required and operation. So 6 different operations are there. One is the facing, then plain turning, then grooving, then taper turning, knurling, then step turning. So all will be shown in video. Okay. And Pradipta sir will discuss if you have any doubt, okay, on this turning shop. So let me share the screen.
Sir?
Yes?
Sir, do we need to write anything?
No need. No. If you wish, then you can write. Understood?
Yes, sir. Yes.
You think that some things are important for you, then you can note it down. Right?
Okay, sir.
Okay. Sound is visible, right? Yes, sound is audible, right?
Yes, sir. Sound is audible.
Yes. Thank you.
Turning session. In the turning session, you have to operate the lathe machines, and in the lathe machines, you have to produce different operations by help of and use of different tools. The first I am telling about introduction about this machine that
Sir, audio is not clear.
first know about the parties.
Sir, sound is very low.
सर थोड़ा इको टाइप हो रहा है.
Okay, then mute yourself. Okay, then I think there will be no, echoing. So let me check. Sound is full. Okay, here it is full. Then
Sir, if you mute yourself, then when you play the video, just mute yourself on Google Meet.
Yes.
We'll stop it.
Okay, thank you.
Turning. Turning is a machining process removes excess or unwanted materials from rotating workpiece by help of cutting tool so that you can produce a cylindrical object. Next I am telling you specification. Specification about this machine. How you specify, why you specify this machine. Suppose after computer engineering, if you want to do a workshop or industry, you have to purchase the machine for your industry or for your workshop. So that you have to purchase the machine from brand company. From the brand company, you have to maintain a note sheet. In that note sheet, you have to mention the specification points. Number one, height of center. Height of center means tops of the bed, center to the center of distance of the jaw. This distance is called maximum height of center. Next, maximum length of bed means this point to this point. This is called bed. Means this point to this point. This is called maximum length of bed. Here we are using the machine. This is the maximum 3.5 feet. 3.5 feet. That means 14 feet bed, 13 feet bed, 12 feet bed. The different numbers, different size of bed, different length of size of bed you can purchase. That means this is small machines and you can purchase about 12 feet machine, large machines you can purchase according to length of bed. Next, maximum distance between two center. Here live center, here will be dead center. In between two center, how many maximum length of workpiece you can hold in between two center, that is most important. You have to mention that when you purchase this machine from brand company. Next, maximum height of maximum swing diameter over the bed and over the carriage. Maximum swing means suppose you holding lengthy type of workpiece, that workpiece or raw material rooted above the case and above the bed. And this center or this axis is very, very important. You have to mention it. What is dimension required when you purchase the machine from brand company? Next, maximum inside diameter of hollow spindle. Inside the hollow spindle, that is important. And next, maximum RPM of machines. RPM means revolution per minute. Next, maximum weight of machines. Next, maximum area of machines. According to you have to occupy the space of workshop or industry. You have to mention that. These are the specification points of this machine so that you can purchase by help of notes. You can purchase from brand company. Telling me about accessories of machines. What is accessories? What is that? What do you mean accessory machines? Accessory means these are the supporter things. They are not part of the machines. These are supporter things of the machines so that you can produce different type of product or different type of job. That means job is one type of accessory machine. This is not a part of machine. This is a holding device and this is mounted in the hollow spindle like line center, dead center, and so many gears here are accessories of this machine. It is assembled back side of the headstock and it is helped to rotate the lead screw, and by rotating the lead screw you can perform a threading operation, and this is work as a accessory machines. Now we have to prepare an experiment by help of these machines, and these are different tools. Before starting off or operate of machines for the experiment, you have to obey the rules or certification before starting of machines. Number one, proper distance from machines you have to maintain to yourself. When you start the machine, you have to wear upload like this. Upload it will be that means cotton cloth, and do not see the hang-wise to the machines or workpiece during cutting time. While likewise, if you get an eyesight, you will get your eyesight, you get another thing. And proper concentration to yourself while operate the machines, and while operating machines and while using the tools, you have to take your concentration very carefully. Next, and you have to wear goggles when cutting the materials from metal, and you may that means this type of cheese will be spread and food type and spread everywhere, and that side make it very dangerous thing. You have to protect your eye by help of your goggles. That is very, very important.
So, dear students, do you have any question?
No, sir.
No, sir.
Sir, would you like to discuss something? Hello, sir.
Yes, sir. Yes, sir. Sir, students have no questions. Sir, one thing we can do, we have one PPT. If we'll introduce them something else about your lathe section, then they may get the clear idea. So,
No, sir, it has already been discussed, elaborated, right?
So this is second class?
Yeah, this one is the second class.
Oh, okay. So students, if you have any doubt regarding this video, because the sound first video sound is not good, second video sound will be much better than this. Okay. So now what we discussed here, my sound is clear, sir. My
Yes. You are clearly audible.
Okay. So now in this video, what we watched one lathe. This one is the lathe machine. Basically, sir already explained that we can manufacture cylindrical component, right? So this machine is meant for only to manufacture cylindrical component, and a single point cutting tool is required there to cut the material. Okay, as you can see here, this machine having such provision where we can mount or fix our workpiece as well as cutting tool. So the workpiece can be fixed there or loaded there in a chalk. You can check this video. There are three jaws. Jaws are there in a chalk, or it is basically one work holding device. And in lathe section, we say as it is a chalk. And there we have to put our workpiece then the chalk has to rotate in certain RPM. So the job is fixed, so that's why the job will also rotate along with that. And then a cutting tool to be mounted in the cutting tool post. Okay, tool post. Tool post is one part of the carriage mechanism. So there what you have to do, you have to manipulate the cutting tool by touching the cutting tool point with the workpiece surface. Okay, then you will able to apply certain cutting force on the workpiece, and the workpiece will get deformed, and this deformation process basically will be plastic deformation process. Okay, permanent deformation process. So more amount of force is needed, and that force we need to apply through the cutting tool on the workpiece for deforming the material, raw material. Okay, so main thing is that how do you deform that? Okay, so that is the thing we have to refer the drawing. So drawing will be given to you. So what the component you want to manufacture, that drawing or in form of projection, like a plan and a elevation and both side views will be given in a drawing sheet, and you have to refer that drawing sheet accordingly. You need to manufacture that. So it is one type of art to move the cutting tool in different direction as per requirement. Okay, so this is the main, task in lathe machine for manufacturing the workpiece there, your components. Okay, so you can see where the chalk is mounted. So that part is called your headstock. So headstock having one gearworks, and that gearworks is called speed gearworks. So speed gearworks is connected directly with the motor. So you know that motor that can give your mechanical power. So from electrical energy to mechanical power it will provide, and through belt and pulleys, both the mechanism like motor and your speed gearworks are connected with each other. So power will be transferred to your speed gearworks. Then speed gearworks has such type of arrangement, we can change the RPM of the chalk. Okay, as the chalk is attached with the headstock or gearworks, so we can change the RPM there by manipulating two or three levers might be there in that speed gearworks. So we have to manipulate those gear positions to achieve different RPM. So that different RPM also required for different material to cut there. Okay, then the extreme end part, just opposite part of the your headstock. So this one is called your tailstock. So tailstock will provide you support to the job. Okay. So this thing we explained in these different parts of the lathe machines. Okay. So now what we'll be watching next video. So if you have any doubt, anything else, so feel free to ask your question. Sir.
Yes, sir.
Second video, please, sir.
Yeah. एक minute. It should be.
Next, different type of lathe machines. Automatic lathe, speed lathe, edge lathe, room lathe, and carpenter current lathe. But we have semi-automatic lathe. You have to operate and you have to do your experiment by help of this machine name is semi-automatic lathe machines. Next, I am telling you about different parts of lathe machines. This part is called headstock. This part
So video is visible, right? And audio is visible, audible, right?
Yes, sir.
Yes, sir.
is called
Yes, yes.
carriage. These are the main part of the carriage, main part of the lathe machines. This is semi-automatic lathe machines. But this main part is assembled by different parts. Here motor, here belt, here squeeze, here the gearbox, here the levers, here the gearbox also. This is the main part, and these are the sub part of the machine. Next, this is the tail stop, and this main part tail stop is assembled as sub parts. This is called tail stop coil. This is the tail stop lock nut, and this is the coil, and this is the lock. And next is that this is called bed. This is also main part of the machine. Next, this is main part of the machine. This is called carriage. But main part of this carriage is assembled in different sub parts. This is called tool push lock, and this is called tool push, and this is called tool push lock. This is called long slide, and this is called cross slide. And front view of the carriage, it looks a H shape. Its name is saddle, and front view of the carriage is called upper. And these are the different parts of the machine. But here I am telling to you different functions of parts of machines. This is the head stop. In the head stop, the holding device, the stop, is mounted with a hollow spindle, and here you have to hold a working center piece of the job by help of tool that is called a jockey. And these are levers. The levers are used for you can get the different RPM. Here given chart A, B, C, D. RPM means revolution per minute. It given 900, 540, 310, 140, 778. These are different RPM. By setting up position of the levers, you can find different RPM machines so that suppose if you want to 90 RPM, so you have to set the lever in A position so that this revolution of a job will get 90 RPM revolution per minute. So here is the gearbox, and by help of the gearbox, you can rotate the lead screw. By function of lead screw, you can perform a head, means screw type of bolt, and you can produce by help of lead screw operations. And here is the back side also gearbox. Next, I am telling about tail stop. In the tail stop, this is called tail stop coil. And in the coil, you have to set a drill bit. By help of drill bit as a cutting tool, you can produce a drill operation. Means when the rotate this coil, the tail stop coil slides against the rotating workpiece and needle motions so that you can create a hole from the solid object. That is called drilling operation. Another purpose it is used for supporting a lengthy type of workpiece. Suppose you are holding lengthy type of workpiece holding, one side you have to hold, another side you have to take a support due to control of vibration. That time it is used. Another purpose it is used for taper turning operation. Taper turn means produce a conical shape of the workpiece. At that time it is used. The next name is tail stop. And this is called bed. On the bed, the carriage. Okay, the next is that carriage. In the carriage, this is called tool post. In the tool post, you have to fix your cutting tool. Just I given an example to you, you can see I have fixed your cutting tool. You have to fix like this, the cutting in the tool post. And tool post rotate one center, just lose this lock, and tool post rotate one center. You can so that you can use four sides of the tool post. You can use at a time. Then if you want to fix the cutting tool post, just push it towards to you and lock this cut push lock will lock and tool post will lock so that it will not rotate in one position. This is called long slide, and this is the cross slide, and this is carriage wheel. That means in this by help of carriage wheel along the cross slide, the cutting tool will move in two axis direction. That is y-axis direction, and this is x-axis direction. Will want to remove the metal from rotating workpiece so that by this way you can move the cutting tool in two axis direction, y and x. So what will get result from x direction and y directions, I will show to you in demonstration and will operate the machine or will start your experiment. At that time I will show. This is choking, and you have to handle, and this is key point. You have to insert here, and you have to hold your workpiece in center of chop and rotate this jockey anti-clockwise direction so that this three part named is jaw, squeeze, and to hold center position of the jaw, and then you have to tie closely. Then you have to fix the cutting tool in the tool post, this part level tool post. I am holding, and this cutting tool you have to set at the proper center height. And you have to build our cutting tool by help of tool post key. First tight, then set the cutting tool perpendicular to the axis of the workpiece, then tight it. Just I am giving you example of turning. You have to rotate the workpiece by on the switch, and this cutting point, the cutting tool, you have to get against the rotating workpiece. Just see here. Just heading the metal, and I am sliding and moving, passing through the axis of the workpiece and reducing excess metal or unwanted metal and producing a cylindrical job. This way is called known as turning. And this type of operation by which machine carried out, that is called lathe machines.
So student, any doubt? Any question regarding this video? Hello?
No, sir. No, sir. No, sir.
Okay. Hello, sir. So, shall I go to the next video? Hello, sir. Wait. Sir.
Yes, sir. Students, you all understood Prakhar 870.
Yes, sir.
You understood it?
So I hope that you understood whatever explained in video, right?
Yes, sir.
Yes, sir.
Little bit.
Okay, sir. Then shall I go to the next video?
Sir, 1 minute. Sir, in this video, we discussed here how to move the cutting tool in two different directions. Okay, so the cutting tool is mounted there in carriage mechanism, and carriage mechanism, as you can see, there are two wheels are there located at downside of the carriage mechanism. Okay, so the bigger wheel, that is called carriage wheel or longitudinal wheel. So if I'll move the bigger wheel, then what will happen? The cutting tool will move longitudinally, or it will move parallel to the job axis. Just recall there that the job is held there in the chuck. Okay, so if I'll rotate the bigger wheel, the cutting tool itself will define a path which will be parallel to the job axis. Then if I'll move the small, and that wheel is called carriage wheel, you can say, or longitudinal wheel, you can say. Okay, then the smaller one, if I'll rotate that, so the cutting tool will move in transverse direction. You can say it is a crosswise direction of that longitudinal axis. Okay, so then this wheel is called as transverse wheel, or we can say it as a cross slide. Okay, because it has crosswise movement facility. Okay, so now operator has the task there to rotate either this bigger wheel or the smaller one, and sometimes we need to rotate parallelly both, simultaneously both, so that the cutting tool will define one angular path, not parallel to the job axis, not exactly perpendicular to the job axis line. Okay, so it will move in a angular way, diagonally it will move. Okay, so now these two things is important, how to move the cutting tool. So for sir explained here that how to reduce the diameter. So to reduce the diameter, we have to move the bigger wheel or carriage wheel, or you can say longitudinal wheel. Okay, so make a firm touch. Cutting tool tip should make a firm touch to the outer surface of the work. Then we have to rotate the longitudinal wheel. As the job is rotating in a rotating condition, then you will be able to remove the material, so the diameter will get reduced. Okay. Similarly, what you will do, if you rotate the smaller wheel, then you can able to reduce the length of the work, because the job, the cutting tool will move in a transverse direction. Okay, so that one section from the length, small section from the length, we can able to chop off. Okay, so the diameter will get reduced. Okay, so these things, and then sir initially told that how to change the RPM by manipulating certain thing in a gearbox. Okay, so this is the thing. We will move to the next video now. Ajinda sir, hello. Sir, your voice is not coming. Please unmute, sir. Yes, sir.
Yeah, yeah.
Next video, sir.
So we can go to the next video.
Yes, sir. Yes, sir.
Okay, sir.
Just I'm telling about different operations. What are operations you can perform by help of this machine? Just I'm telling you, listen carefully. First operation, if you want to do fetching operation. In the fetching operation, what is result you will get by this operation? Suppose you are holding a workpiece length is 100 mm. If you want to reduce the 95 mm, so you have to do the fetching operation. Mean, this is your cutting tool, and cutting tool will move to y-axis direction to the workpiece, so that you can reduce the length of workpiece. This way, this is called fetching operation, and it is produce a flat surface. This is the fetching operation. Next, plane turning operation. Plane turning will suppose you are doing, you want to reduce the diameter. Suppose diameter giving a 25 mm. If you want to do 20 mm or 22 mm, that means you have to start the cutting tool from end of the workpiece. It will slide along with the axis of the workpiece in parallel wise, so that you can reduce the excess metal on the diameter, so that you can produce a cylindrical object that is called plane turning. Suppose in the solid object, if you want to create a hole, that is called drilling operation. Suppose you are holding here. Suppose you are holding here workpiece here, in holding device, this is chopped, and by help of drill bit, this is called a drill bit, and this drill bit you have to insert here, and at the rotating time, you have to set that this is called tailstock, and you have to rotate this wheel so that the dead weight will slide in linear motions against the rotating workpiece. It will create a hole. That is called drilling operation. Next, I am telling the step turning operation. Step turning operation means in one axis diameter, suppose you have to produce a different diameter in one axis step by step, that is called step turning operation. Suppose you want to do produce a conical shape from the solid workpiece or solid cylindrical workpiece, you can produce a conical shape, that is called taper operation. So these are different. Suppose you have to produce a screw type or bolt type or knot or bolt, you can produce by help of this machine, that is called threading operation. So these are the different operations by help of this we can produce, so that by help of different operations we can produce a solid object and or a product by help of different operations.
Hello. So
Yes, sir.
any doubt, student?
Yes, sir. Yes, sir.
Please ask if you have any question.
Sir, can you share these videos?
Yes, we will give you the link. Okay.
Yes, sir.
So no doubt.
Sir, is it, sir, during cutting that, like Pradita sir mentioned that we used to rotate both the wheels to cut at an angular direction. Then during that, is there any way to get precise angle or something like that? Because
Very good question. Suppose we need to do that in champering operation. Okay, so we'll show that how to do champering operation. Sometimes in a drawing, it is mentioned like for champering the angle to be 45 degree. Okay, so there we have to if I'll rotate the both wheel there parallelly, then the cutting tool, see that the job axis, let's say it is x-axis, and the transverse axis, let's say it is y. Okay, so what will happen in first quadrant? So there the cutting tool will move, and in between the x and y axis, so it will be around 45 degree there. Okay, so in a certain angle, in a diagonal, it will move. Okay, so this is required only for some customized operation like champering all this. So there we can do that. Else we have one also facility there in that compound rest. So we can set the compound rest to our required angle. Suppose let's say I need 60 degree, so that angle I can set there also. Okay, so the cutting tool will move there 60 degree with respect to the axis line. Okay, so we will be discussing that how to do champering, and that time we need to rotate the both wheel, both transverse wheel and as well as that longitudinal wheel, to move the cutting tool in a diagonally to move the cutting tool there. Okay, so this
sir,
is the question.
sir, if we are rotating, then won't be there be a human error?
There may be human error. See, we are now talking about the conventional lathe. Okay, so in conventional lathe, so one operator has to stand there all time to do all operations. Okay, so there may be human errors there, maybe machine error there, maybe other operational error may arise because of that improper operational procedure. But there is another version of this lathe is called CNC lathe, computerized numerical control lathe. Okay, so there the operator has to do nothing more in that. So he has to or she has to write the program. A programmer has to write there the program. So that is a programmable lathe machine, and the accuracy will be good, and the productivity also will be good. Surface finish will be much better than the conventional lathe machining. Okay, so there all these advantages we are going to get. But in conventional lathe, so operator should be more experienced to produce a quality based job. Okay, but still no machine, uh, you can say that it is 100% accuracy, because there may be some error there. Even whenever we are measuring the component after machining or after removing the material, so that measuring instrument may have also error. So you cannot say the 100% standard value will get. So if I will measure by certain vernier caliper, it is 10.04 millimeter. In another vernier caliper, you will get 10.02 millimeter as the reading. So that's why they have made one provision there, that what will be the tolerance there. Okay. So for every dimension in drawing, so there will be a tolerance. Okay. And the tolerance may be bilateral tolerance or maybe unilateral tolerance. Okay. Let's say in your drawing, the length of a component is given that to be 100 millimeter, and there may be a plus minus tolerance, maybe 0.04 millimeter. You can increase the diameter, or you can decrease, if the diameter get decreased 0.05 or 4, then it is manageable. Okay. So before to start the work, we need to check that what is the accuracy or the tolerance that has been given in the drawing. So as per that accuracy, we have to work. If the accuracy we could not maintain there, then the job has to, we have to reject the job there, or the job may need rework. Okay. Again, that to be sent to the manufacturing department or the forming department. So they will do some rework there to maintain again the accuracy, and those dimensions should come under the drawing size, and they should come under the tolerance limit what have been given to them. Okay. So it is not that it is giving you that to maintain 45 degree, and if it will be 44 degree and some minute, then also it will be acceptable if it is coming under that tolerance range. Okay.
Yes, sir.
Understood or not?
Yes, sir.
So, sir, shall I go to the next video?
Yes, sir. Yes, sir. Yes.
Okay.
Okay, dear students, now you have to start the estimate, and you have to color a drawing sheet, and the drawing sheet giving the multiple lathe operation.
It is audible and visible, right?
Like this type of product, you have to prepare by help of the
Yes, sir.
machine
Yes, sir.
and use of tools. First, you have to study the diagram, where giving dimensions, which diagram, all the things you have to study. Then, according to shape of different operation, you have to color the tools, different tools from counter, and by job tools and machine, you have to start. And in this product or shape of product, 6 operation you have to do. Number 1, facing. Number 2, plane turning, grooving, taper turning, nulling, and step turning. Step by step, all operation I will show to you, and how you operate the machine, how you use the machine, how to cut the metal by help of cutting tool, and how to hold or how to set or workpiece in holding back. All the things step by step I will show to you, and you have to study. Okay, that's all study. This is your, first you have to collect raw material according to diagram size. Suppose diagram total length given 30, 10, 40, 40, 15, 55, 55, 5, 60, 60 plus 15, 75. Total length is 75. That means above this length, or that means more than this diagram or length, you have to collect raw material. That means this length is 80 mm. If you confuse, you can measure by help of vernier. This is vernier caliper, and this is knee, this is abdomen also, and here by help of this you can measure here, and you know how to measure the vernier caliper. This is the main scale, and this is the vernier scale. In the vernier scale, the rule consigned to main scale division. This is the 80, 82. That means total length of workpiece 82, and maximum diameter final product, that is 23 mm. That means more than the 23 mm diameter you have to collect from raw material. That is here given 25 mm. And now this is exact raw material or suitable raw material for this estimate. Now starting, and how you hold the workpiece in the holding device, the chalk. First, you have to collect the chucking. This is called chucking, and this is handling part, and this is the key part. This key part you have to insert here. After inserting, this is cylindrical workpiece, and this is mild steel, length 82 mm and diameter 25 mm. And more length, you have to divide it two parts. Minimum part of length you have to hold, maximum part of length of hold you have to hold outside. Means you have to keep in center position, then rotate anti-clockwise to chucky. These three part name is jaw. These are called as a jaw, and these are holding your workpiece. And rotate anti-clockwise direction and tight closely. After tying, you have to study the three jaw contact outer surface or not. If you contacting outer surface equally, that means your holding process is right. Now you have to study after on the switch it is rotating uniformly or not. After on machine, it is rotating uniformly and also vibrating. Now this is wrong position. Again, you have to set the proper center level. That means this axis of workpiece and this axis of the holding device should be one axis. For this cause, you have to take help another, that is marking block. Marking block, in the marking block, this point you have to keep outer diameter of the workpiece, and it will be just gap top surface of the workpiece, and rotate to chalk by hand. Check which side is touching to marking point and which side is maximum gap. And this is maximum gap, that's why it is vibrating. See here again, it is vibrating up and down. That means this axis and axis of workpiece not concern each other. Again, just loose this workpiece by help of chucky, then set proper way and tight, then check.
Student, any question on this video?
सर
Yes.
सर वो जो मार्किंग ब्लॉक में क्या हुआ सर, समझ में नहीं आया ठीक से।
वो मार्किंग, हाँ बोला, मार्किंग ब्लॉक जो है वो एक इंस्ट्रूमेंट है, वो सेंटर चेक करने के लिए होता है. अब एवरीबॉडी कैन अंडरस्टैंड हिंदी और विल स्पीक इन इंग्लिश?
Yes, sir, we understand Hindi.
Okay. So now see, we have two different, हमारा दो तरह का चॉक होता है. एक चॉक तो 3 जो चॉक है, और जो मैकेनिकल चॉक है वो चॉक पहले समझ लो क्या है. चॉक ए है, कोई जॉब को आपको अगर होल्ड करना है तो आपको एक होल्डिंग डिवाइस चाहिए, और हमारा लेद में जो होल्डिंग डिवाइस है अभी उसको हम चॉक बोलते हैं. तो चॉक में, जैसे हमारा माउथ में 2 जॉ है, तो ऐसे चॉक में 3 जॉज होता है और 4 जज होता है। 3 जज जो है वो नॉर्मली यूनिफॉर्म वर्कपीस, ज्योमेट्री वर्कपीस के लिए अप्रोप्रिएट है। लाइक सपोज हमारा एक वर्कपीस है and that having what circular shape, exactly you can say that which is uniform circular shape or diameter. So then we can select the 3 judge job. Okay, then why 4 judge job there? Suppose we have a workpiece and it is not regular in regular shape. Let's say it is elliptical or maybe prismatic job, maybe square, rectangular, or your any other sides are there. So there, what I have to do? It is too difficult to hold that sort of irregular shape job by 3 judge. Okay, so there we need 4 judge, because all 4 judge we can individually adjust the position of all 4 judge by rotating the screw there. Then what will happen? We can exactly locate the workpiece, irregular shape workpiece at the center. Means see, any workpiece that may have one center point, and that center point or center line should match to the workpiece to the chalk center line. Okay, so both the center lines should coincide with each other, and then we can say the job will move, will not move eccentrically. Okay, and if the job will move eccentrically, then it will be too difficult to cut the material. Some one side or in one axis it will cut more material, and at opposite side it will cut very less material, because the job itself is held there eccentrically. So the after machining will get a eccentric job, will not get a concentric job. Okay, so now this instrument is used there to check whether the workpiece is at center, it is located at the chalk of the center, or whether the workpiece center line is coinciding with the chalk center line or not. So this is the instrument by which we can verify easily. Okay, but sir here used this one to only show the use of the surface gauge or marking block, but actually it is not required for the 3 judge chuck. If we have 4 judge chuck, other machine, some machine having 4 judge chuck, we have 15 numbers of machine for you, and there some machines having 3 judge and some having 4 judge. Intentionally we fitted their 4 judge for irregular to machine irregular shape job. Okay, so this job is not an integral this chalk is not a one integral part of the lathe machine. We can replace it by 3 judge chuck. If already 3 judge chuck is there, we can replace it by 4 judge chuck. And also the chalk size also we can change by replacing it by a new one. Okay, so this is not at all one integral part of the lathe machine. Even for complex shape job, so we have to again use some other type of fixture, not this. If this is what that chalk will help to do that. Okay, so now this surface gauge has a scriber, and one what you can say that bend or offset type scriber. So we have to that we need to check somewhere, we have to adjust the height of the point of the marking block or surface gauge. So there the point where suppose fan B it is touching, and we have to check the opposite side. If there is a gap, then we have to down to the job to downside. Okay, so by adjusting the four judge. Okay, so this is basically required for the to locate the center of the workpiece, whether it is matching with the chalk center or not. And this process, remember student, this process is called truing. Okay, truing. Okay, or you can say centering process simply, but the exact appropriate word is truing. Okay, so this is a truing process sir explained here, though it is not required for 3 judges, but intentionally he explained it to know the use of that marking block there. Okay, so it is clear now.
Yes, sir.
Okay. So shall we move to the next video now?
Yes, sir. Yes, sir.
Okay.
And here this side is touching means just slightly down. Now it is center means this axis and axis of the holding device and axis of the workpiece constant to each other. So here you can study in this chalk, the holding device name is chalk, it is giving 3 jaws 1, 2, 3. That's why it is called self-centering chalk. And just adjusting the center by manually. But in the so many holding devices for the chalk, and by processing you have to do the centering process. Centering process means axis of the workpiece and axis of the holding device should be one axis. But here just adjusting by pressing or by hammering to the workpiece, and you are matching the axis of the workpiece and axis of the chalk in one axis, that is centering process. Now it is now centering complete and then tied to your workpiece forcefully. Otherwise, if you lose it, then you cut the metal by help of cutting tool. It may be loose from the workpiece or holding device, and will create danger accident close to you. And your centering process now over. And for the centering process, I have taken help. This is jockey and this is marking block and also hammer. Now centering process over. Now I am going to setting your cutting tool, and this is your cutting tool, and cutting tool metal is high speed steel. In the cutting tool given 4-sided, okay, and length is 3 inch and the diameter is 3 by 8 inch. And this is, that's why it is called 38 into 3 inch high speed steel cutting tool. In the cutting tool, you have to create a cutting edge. Where the cutting edge? This is the cutting point, and this is the cutting edge, this is the cutting edge. Here, different angle of the cutting tool, you have to maintain. Why? Now, if you will cut the metal direct to the cutting tool, direct use of the cutting tool with the workpiece, that means we cannot cut the metal. Now, surface of the workpiece and surface of the cutting tool, you have to create a clearance angle between them. Otherwise, you cannot cut the metal by help of cutting tool and from the workpiece. That's why you have to create an angle. Here is clearance angle, this is the side clearance angle, and this is the right angle, and this is your cutting point. That's why it is called point cutting tool. When you set the cutting tool, the cutting point should be top side, not like this hole, not like this hole, not like this. Why? Now you are rotating your workpiece in anti-clockwise direction towards me. That's why force applying vertically to the cutting point. That's why cutting point should be top side, not like this. You have to setting your cutting tool like this way in the tool post. In this position, cutting point cannot cut the metal smoothly. That's why cutting point should be set at the top side position. That means in the tool post. Now, already discussed about the cutting tool. This is the high speed steel, and this is the cutting point. This is the clearance and similar given clearance angle, different angle, side clearance angle, side angle, front rack angle, top rack angle, and this is the cutting point. Now this cutting tool you have to set or you have to fix in the tool post. This is your tool post. Now tool post 1, 2, 3, 4 side given. So you have to hold your cutting which side. Now which side nearest to workpiece or cutting point should be perpendicular to the axis of the workpiece. In that side you have to set your cutting tool. That means it will be set in this side. That means cutting tool will be perpendicular to the axis of the workpiece, so that you can hold your cutting side. This side it will be easy or it will be suitable. Before setting your cutting tool or cutting point set side, the cutting point should match the center of the workpiece, so that you can cut the metal the front side and there is no metal remain in the center of workpiece, so that the cutting point should exactly match the center of workpiece. That's why now study cutting point is just down from the center of workpiece. That means cutting point should be matched with or exactly match the center of workpiece. That's why you have to use another tool that is called as a seal. That is called a seam or packing, and you have to set the packing under the cutting tool, and this packing should be made in parallel front side, and you have to set the packing and on the packing, and this small length of cutting tool hold from the outside of the tool post, and this side, this small length of cutting tool hold inside the tool post. Now see here, set is by your hand and try to knot, and now observe it is exactly matching to the center of workpiece or not. Not exactly, just down from the workpiece. That's why like this packing you can use. You have to set, and now again check. It is exact matching to the center. That's why now you have to tight. Before tightening tool post, first you have to lock the tool post and tool post knots rotate in one center. First lock the tool post, then tight by help of tool post key to knot. And above the cutting tool, just give a packing to proper tightness so that the cutting tool not loose, and you have to tie it properly. Otherwise, cutting tool loose means it will create dangerous, and when apply the force during cutting time, metal from the workpiece. Okay, tight. Now you have to reduce the length by help of facing operation. Length means just 1 mm or 0.5 mm or just 0.2 mm. You have to approximately reduce. That means you have to set the tool post angle in 45 degree. That means the cutting point, exact cutting point will match to the face of the workpiece, so that you can create a clearance angle front side and back side of the cutting tool. Now setting over, now starting basic operation. Now first you have to on the switch, the lever, slide towards to you, then cutting point will take to end of the workpiece, rotate to carriage wheel, and then cutting point here. That means cutting to move x directions and cutting to move y direction. That means you will toss so that you can toss the cutting point outside diameter of the metal. Now rotating cross-slide wheel in y-axis directions, not touching. Now carriage wheel just touching both sides operating and touching corner of the workpiece outside of the workpiece. And now slowly rotate to carriage wheel, slowly clockwise directions, and now cutting point of the cutting tool slide up to center, that is in y-axis directions. Now approximately 0.5 mm meter reducing length side of the workpiece and producing a flat surface. That's why it is called facing operation. I have told you, by facing operation you can maintain the length and you can produce the flat surface of workpiece or raw material. Now see here, after complete facing operation, here is some metal element. So exact metal not removed. Why? Now this cutting point is not matching exactly to the center of workpiece. That's why it is just down. That's why you have to match the cutting point to the exact center of workpiece properly. And another packing. So here is some metal remaining left here. You have to remove this metal front side of the workpiece. That's why again just loose the cutting tool, and you have to set the cutting edge or cutting point of the cutting tool properly to the mesh center of workpiece. This way, like this thickness of packing, I am adjusting and setting it under the packing and properly. Then again setting the cutting tool. Now and tightening the cutting tool. Properly setting the cutting point, matching exactly center of workpiece or not. Okay, result matching. Now I'm going to on switch and again starting. Now removing this remaining metal. Now this is facing operation. This is called facing operation. This is
So student, any question?
Any questions, students?
No, sir.
No, sir.
Okay. So we already explained all these things. Ankit. So here only one thing I can add here, that a single point cutting tool is required to cut the metal. So multi-point cutting tools are not required. So the tool having only one point or cutting point, that is called single point cutting tool. Okay. That is being utilized here for cutting the material or to remove the material here. And multi-point cutting tools, like you can say that drill bit having 2 points, cutting points. So we can say multi-point cutting tools to drill bit. But if you have a milling cutter, other machine tools we have, so they are milling cutter, they having multi-point, so they are multi-point cutting tools. But for a lathe operation, basically we need a single point cutting tool. Clear? And that cutting tool material, to select the cutting tool material there, the first requirement is there or criteria to select the cutting tool material. That should be the hardness must be maximum. Okay, then you can cut the metal. Then the other mechanical strength like tensile strength, compressive strength, bending strength. So these three things should be much better for a cutting tool. Okay. Then the wear rate, so it should be much higher. The hardness should be much higher there. Strength must be good. Then the cutting tool wear rate should be minimum. Okay, because that there all time during cutting, there all time will be a close interaction of cutting tool and the workpiece. So there will be friction there. So we should select such type of material that must have less wear rate. Okay, and then the because due to the friction, so more heat will be produced there, and some heat will be transferred to the cutting tool and some to be the workpiece, so that the cutting tool should withstand that much of temperature. Okay, so here we are talking about a cutting tool material, that name is high speed steel. So high speed steel material chemical composition, if I mention here, it will be iron, carbon, manganese, then tungsten, vanadium, chromium, and sometimes titanium. Okay, so these are the alloying elements are mixed together with the iron, and iron will be the base element there. It is a basically ferrous material, but it is a high alloy. Okay, so that material we said as that solid solution we said as high speed steel, and that high speed steel material we have to redesign or reshape to single point type. So we have to bring it to appropriate geometry, then that can be utilized as the cutting tool there to cut the metal. So this high speed steel material is not much higher grade cutting tool, but still it can cut all sort of carbon steel. Okay, so medium carbon steel or mild steel or low carbon steel material. So easily we can process by using a single point cutting tool of high speed steel. Okay, so these are the things basically we discussed here in this video.
Okay,
So
sir.
should we move to next video now, students? Please respond, students.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Sir, next video, please.
Yes, sir.
Okay, next we start plane turning operation. In plane turning, before starting of plane turning operation, you have to study the diagram. Here length giving 30 mm and here diameter giving 19 mm. But here diameter 25 mm and length is 30 mm. That means you have to just mark by help of ruler and chalk the where is 30 mm from end of workpiece. And now 30 mm here and just marking 30 mm. Up to 30 mm length, diameter should be 19 mm according to drawing sheet. So here diameter now 25 mm. So that means layer by layer, that means number of cord you have to apply, that means you have to cut layer by layer. How cutting the sheet? Before in this position of tool post, we have completed facing operation. Now you have to change the angle of position of the tool post. That means was to axis the workpiece in 90-degree position of the cutting tool. So now it is set, and now we have to fix a lock or tool post lock. Already machine set up over. Now on machine and just cutting point, just touch of the diameter of workpiece. Just touch, and when the touching the cutting point outer of the workpiece, at the time you have to observe here cross-slide wheel. Here giving division, and this is the fixed marking, and these are similar divisions given. Why marking? Now you have to apply the depth on the workpiece so that you can cut the metal easily on the diameter of workpiece in proper way. That means here marking the stretching 68, and this 68 is the reference position or reference marking to apply the depth of cord on the workpiece. And here 68 will not disturb the cross-slide wheel, and just cutting point removed from the surface of the workpiece towards to outside, and from this reference position just turn 15 division in clockwise directions. Now here 73, this is the 73 the reference position, 73 plus 15 division. 88. Yes, 88. That means cutting point you move toward the axis of the workpiece 1.5. That is called depth of cord, and metal removes 3 mm. Okay, and 1.5 mm is called depth of cord. Here, arranging of what is called depth of cord. Depth of cord means particular distance of the cutting tool towards the axis of workpiece. That distance is called depth of cord. That's why here is applied 1.5 mm depth of cord. When you cut the metal, it will reduce 3 mm. Why? When after cutting the metal, it will measure the diameter of workpiece, and it will be measured both sides. That's why 1.5 into 2, that is 3 mm, will be reduce the metal of the workpiece. Now starting, and we have to just start the cutting point from end of the workpiece. At that time, the cross line will be constant or fixed. and your carriage will be rotated anti-clockwise slowly, very slowly, and very slowly rotate towards to marking, that means 30 mm. Very slowly rotate carriage wheel towards to 30 mm and just going to reduce the diameter of workpiece, and now doing plane turning operation. By use of this operation, you getting result that reducing the diameter of workpiece. That means smoothly you can maintain the diameter of workpiece according to requirement size or dimension. Now marking over without rotate this crossword wheel, not touch anything here. Again remove the carriage wheel outside. The next part you have to apply. So here is 88, next 15 division now, diameter is 42 mm. Before that 25 mm, now diameter 22 mm. And you have to do 19 mm. Again 15 division. You have to mark here. Now it was at 88, again 15 division.
103. 103.
103. Yes. Now cutting point. Move work axis 1.5 mm. That is that the part I told you. Then slowly touch end of workpiece. Again rotate. So here you can observe what is called feed. Feed means distance of the cutting tool in one revolution, that is called feed. Means feed rate will improve or increase or 3 mm or 2 mm instead of 0.1 or 0.2. The surface will be create roughness. Or feed rate will be 0.1 or 0.01. The surface, cutting surface will be smooth. That means you can vary here feed rate. Feed rate will increase or decrease. In increase time, what is getting result on the surface, and feed rate will decrease. What they getting result? The surface of the workpiece. And a slowly rotate means feed rate will be decreased, and rapidly rotate to the carriage wheel, feed rate will be increased, surface will be roughness, will create roughness. Now going to our plane turning operation and cutting point just touching to 30 mm, and here dimension 30 mm length, diameter will be 19 mm. Now your plane turning operation over.
Okay, students, what is the name of this operation we did in this? Students,
Can you repeat again what you are?
which operation we here watched? What is the name of the plane turning? So by plane turning, what we can do? What the changes can be made in the workpiece?
To reduce diameter.
Sorry?
To reduce the diameter.
Yes. We can reduce the diameter by plane turning operation. Okay. So we watched here carefully, the cutting tool or single point cutting tool should make very closer to the workpiece, and it should firmly touch to the what? It will firmly touch to the workpiece outer periphery. Then we need to move initially the transverse wheel. So when we will move the transverse wheel, so it will move crosswise, I mean opposite to the job axis. Then the cutting tool will make a penetration into the workpiece surface, and suppose it penetrated into the workpiece surface, let's say 0.5 millimeter. So we have a scale there, we can map or we can check that what is the depth of cut there. So when it is penetrated into the workpiece surface 0.5, let's say, so then we have to immediately change the movement of direction, I mean direction movement. So how do you change that? You can rotate there that the longitudinal or the carriage wheel, the bigger wheel. So when you will rotate, so 0.5 millimeter material will get reduced on the workpiece surface. Okay, so the radius will decrease there by 0.5 millimeter. So diametrically it will be twice of this. Means I reduced their 0.5 millimeter from the radius because it is one radial component. So the diametrically it will be 1 millimeter. So in a single pass, if I have given their 0.5 millimeter as depth of cut, so 1 millimeter is going to reduce there from the diameter. Okay. So let's suppose the diameter initially was 30 millimeter and I defined the depth of cut, that is 0.5. Then the diameter, final diameter will be, or after machining, the final diameter will be 29 millimeter. Okay. So now sir told that how to find out the depth of cut. This is one essential cutting parameter. So depth of cut. So in this depth of cut can be evaluated by the on machine diameter, or capital D you can take for that, and minus machine diameter. Suppose let's say it is D1 and D2 upon 2. So D1 was 30, let's say, and I, after doing machining, I got the 29. So 30 minus 29 upon 2 will be 0.5 millimeter is the depth of cut. Okay. So this is the one cutting parameter, and one more cutting parameter is your feed. So what is feed? Because machining operation is nothing, it is working under that finish pool. We have to make such arrangement so that there will be a relative motion between cutting tool and work. So here in lathe case, the workpiece is rotating, but it is not changing its position in terms of its axis, and the cutting tool is taking linear movement. Okay, so we can say there is relative motion between these two member. So the we can able to cut the material. So the machining or material removal process based on the this finish pool, we have to establish relative motion between workpiece and a cutting tool. Okay. So now feed is another parameter that sir explained here. Feed is nothing. When your cutting workpiece will take one complete revolution, because the cutting to the workpiece is rotating there, and when it takes one complete revolution, meantime, because there is relative motion there of cutting tool, so cutting tool has to move there. So when it takes one complete revolution, meantime cutting tool might have moved some distance there. Suppose that distance is x millimeter. So now this x millimeter is your feed. And see, it is millimeter per revolution. So per revolution, the linearly the cutting tool traveled there, and that distance can be counted as very small distance it will be. Okay. So why it is important? Because precisely we have to maintain the feed rate. If the feed will be very less, then you will get very good surface finishing, and the distortion chances of material will be also less. And if I will take more feed rate, then the rough surface we are going to create there more, and again the material may deform. Unwanted deformation may be occur there because of that higher feed. Okay, so that's why. And again, if you make it very less speed, then the productivity also will going to deplete. So that's why carefully we have to justify what will be the ideal feed rate to maintain the job quality, surface finishing, as well as to maintain the appropriate productivity or efficiency of that cutting. Okay. So the feed is more important. Then another thing finally, sir explained that the cutting velocity or cutting speed. Okay, so that cutting velocity is nothing. It is one important parameter, also cutting parameter. So it is one type of tangential velocity there. So that can be defined by this formula pi for the length, pi dn upon 1000. So pi everybody know that is one mathematical constant. Then d is the diameter, on machine diameter. N is the revolution. I mean number of revolution per minute. Okay, then upon 1000. Again one constant is coming. So pi dn upon 1000. So that can be expressed in meter per minute. Okay, because 1000 is there, is divided there by 1000. Okay, so it will be meter per minute. So this tangential velocity also make a sense important factor there, because if I will put the optimum cutting velocity there, so we are going to get good quality job along with the good production efficiency. And if I will put their improper cutting velocity, then the cutting tool wear rate will be more, and the surface finish may not be good, the dimensional accuracy may not be good, and there may be unwanted distortion in the raw material due to high amount of force we have to apply to deform the material. So these are things may occur. Okay, so these are the things we discussed in this video. Some cutting parameters, again how to perform plane turning to reduce the diameter. So is it clear now to all?
Yes, sir.
Okay.
Yes.
Satyabrata 745. Are you there, Satyavrat? Please respond.
Yes, sir. I am with network issue, sir.
Okay. So now we'll move to next video. Okay.
Sir, I am audible or not, sir, because I am having some network issue.
Your voice is not coming clearly here. You are not
Sir,
clear.
he is suffering from network issue.
Sir, I am getting some network issue.
Mic off karo.
Over diameter.
Okay, okay. Now it's okay. Now watch
Okay,
this
measure
video.
here. Now diameter 19 now. Okay. And here creating a corner. If you want to remove the corner, that is by help of chamfering operation. Means 2 and 45 degree. So see here in chamfering operation, just remove the edge of the workpiece and you have to set the tool posts like this angle, and by help of this edge you can toss here and just swing to you, and this edge, by help of this edge you can reduce your edge of the workpiece. Just going to on machine and just going here and just reduce the corner of workpiece. This is called chamfering operation. By help of this operation you can save the edge of diameter of workpiece, and when match the diameter with the female part or male part, at the time it will be the contact easily to mesh or press the diameter inside the diameter. It will be easy to press it and easy to fit it. Okay, now one side job over and going to open workpiece from the job and start back side. Now over is your main turning facing one side job over. Now I'm going to start this side device. Now again setting here, and you have to set your workpiece center position. You have to observe there should be contact at the surface, because this is TH job, and also this is called self-centering job. Automatically will be center, then tight workpiece by help of jockey tightly. Again you have to do plane turning operation. because you have to study your diagram. This side given 19 diameter, this is also grooving operation, this is a taper operation, this is nulling operation, so many operation given. That's why first 15 plus 5, 20 mm length, diameter should also 19. And marking by vernier, to give mark. Again, same process, you have to do plane turning operation. That means so that you can do the diameter into 19 mm. Again, main machine, on machine, same process, cutting point touch outer surface. You have to take reference points from after depth. Here, cutting point touching the marking line 21. Remove, then rotate 15 division, and this division is reference point after the depth. 15 division, rotate, and cutting point move toward the axis 1.5 mm, that is depth of cut, and touch the cutting point end of the workpiece and rotate to carry wheel slowly, and you can reduce the diameter and apply the number of cut. That means now one layer cutting, that is called one cut. Here I am telling one thing, cutting speed means, and cutting speed and RPM of the machines different. Cutting speed means peripheral speed of workpiece over the cutting tool. That is called cutting speed. We'll find the cutting speed. At the time you have to use the formula CS is equal to or velocity, that is pi dn by 1000. P means 25 mm, N means which RPM you have to run the machine. Here RPM is at machine lever B here, machine lever F means BF in the chart is given 10. That means spindle RPM or chalk RPM or workpiece RPM same. Here 010 RPM is N value got, and B value is the 25 mm got, and pi dn by 1000. By using the formula you can find the cutting speed. Okay, that is very, very important. And going to apply second plot. So here again second plot is that 15 division. Now it was 41, and going to your diameter into according to OLC dimension 19 mm. Okay, now stop machine. Here fix and you can measure. You are getting exact dimension not? No. 1 mm depth. Again here apply 10 division. 1 division to 1 division is 0.02 distance. Then hard cut to getting exact dimensions. Apply hard cut to getting exact dimensions, and slowly rotating carriage wheel, and feed rate is very less, and getting smoothness from the workpiece surface. again getting here corner of workpiece, and you have to remove the corner by applying sampling operation. So what is result of sampling operation? You know that already told you. Again set the tool push angle in 45 degree by help of cutting edge. You can reduce the corner of workpiece. That is called sampling operation. Now over.
Student, any doubt?
No, sir.
Same thing we repeated here. Same thing.
Yes, sir.
Only we reduce the diameter here by plane turning.
Yes.
Sir, next video, please.
Okay, sir. Then shall I go to the next video?
Yes, sir.
Hello.
Yes, sir. Please.
Okay, okay.
Now going to do what? Nulling operation. For nulling operation, you have to use the tool, nulling tool. Here the two ruler, and these are made of high carbon steel. And here is a cross ruler. By help of this ruler, you can create a null. It means gripness, you can produce a gripness. So while doing the gripness, when the rotate, a cylindrical job of smooth cylindrical job rotate by hand, and it will be sleeve. And you have to prevent the stiffness, you have to produce, you can produce a gripness. You can observe in the cap of, that means cap of the bottle. When you're rotating the cap of the bottle, you can observe, you can study on the cap giving a gripness. Like this gripness you can produce by help of this nulling tool on that workpiece. See here how to do it. I am going to lose this tool and work of this tool will work. So like this way, this nulling tool, this ruler should be set as a proper centroid to the axis of the workpiece and taking under the tool and one pecking on the cutting tool setting to proper centroid. Now tight forcefully, otherwise you lose and create dangerous then. Again set 90 degrees to the axis of the workpiece. Then lock the tool push by help of tool push lock. Then after the taper operation, you have to mark 10 mm. 10 mm by vernier. You have to mark by help of chalk. On the 10 mm, you have to do nulling operation. First, two ruler set as a proper centroid, up and down. Bottom side ruler should be touched and up side ruler should be touched on that surface of the workpiece. Just touch, then start the machine, and two ruler will be rolled. Then press again So by help of cross slide, just slide it. Now nulling operation over. You can observe here clearly that gripness cross null created, and here is a nulling operation. Okay.
Students, in this,
Yes, sir.
we did both operation now. Print or sir, yes, knurling and taper turning. Okay. So knurling operation, you can check that there are two wheels of a tool. So these two wheels should be much more harder than the workpiece. And when we'll make contact these two wheels simultaneously with the work surface, so because the wheels are serrated in opposite direction, okay, so you can check the wheel having some grooves, and they are serrated in opposite directions. And when both wheel will get pressed on the workpiece surface, so they will deform there. I mean, they will make a mark there, pressing mark, and you will get a crisscross like pattern or a diamond shape like pattern. Okay, so it's not important that how what type of pattern we are going to make there. That is not much important. The important factor is there if there is a requirement there to increase the roughness, because due to the machining, so the outer surface might be more smooth, and we need more grip capacity there or value. So we have to make it more rough. So this is one method by which we can make the outer surface of the workpiece rough. Okay, so that anybody can easily grip that, and it can rotate. If we suppose, let's say there is one electrical instrument where we have to rotate the knob, and we have to precisely adjust the suppose, let's say, current there in milliampere. So we have to minutely adjust the current there by rotating the knob. And if the knob having good gripping value or capacity, then easily, precisely we can rotate that. Okay. So this is one example I can give you, because we are doing there the nulling operation. So anybody may ask you that why nulling is required. So you should say to only increase the surface roughness of the uh, component, we need that. But how we are doing that, these are two wheels are more harder, to be more harder than the workpiece hardness value, and we have to press them parallelly or simultaneously. Then what will happen, it will press the outer surface because the job is rotating there, and it will make crisscross like formation or pattern, because the both wheels are exactly opposite, exactly serrated in opposite direction. Okay. And the taper turning is nothing. It is one type of profile where the diameter will not constant uh, at any instant. Okay. So if you check the taper portion, the diameter will not be constant or same. Somewhere, suppose the initial diameter is D1, and gradually the diameter will decrease towards the other end, opposite end. Okay. So at any instant, if you check, we will not get a constant diameter. We will get two different diameters as D1 and D2. Okay. So this we can manufacture by help of the compound rest. So the compound rest is just a is the member of a carriage mechanism where we are mounting the cutting tool just below to that one. You can check in this screen, one rectangular component having one wheel or rotating arrangement. So that is called compound rest. So on the base of the compound rest, graduations, angular divisions are cut there, and we have to find out the taper angle first. And if my taper angle, let's say 10 degree, so we need to mention there that 10 degree we have to match the compound rest what datum line with the 10 degree. So if it is you understood it, it's okay. Else we can show you the once more that video, so you will get the idea how to set the angle. Okay. But the important thing is how do you confirm that yes, I need a taper part, which taper angle will be some degree, let's say 10 degree. So how do you find out? So there is one formula there, so by which we can get that. So suppose let's say the taper angle value is alpha, or alpha by 2 also half of the taper angle you can take. Okay, so there is one formula there. Okay, so the major diameter minus a smaller diameter upon 2L, tan inverse of that. Okay, so that already might have explained to in the theory classes, and if it's not, then we will explain it again also. Now these two operation we did in this video. One is it nulling, another is it upper turning. Now it is clear to student all.
Yes, sir.
Okay.
Yes, sir.
So I'm going to the next video. Okay.
Yes, sir.
After study of drawing sheet, this part over, now I am going to do this part, that is taper operation. Conical surface is given here. Here is large diameter, here is a small diameter. In taper conical surface you can produce by help of this machine. So how to produce, just I am giving example, or by demonstration I am telling to you. This is called taper operation. Taper operation means gradually increase or decrease the diameter along with workpiece. Means here is a large diameter, here is a small diameter. Gradually increase and decrease the diameter along with the workpiece, so that you can create an angle to the axis of workpiece. That angle you have to find. Data given, larger diameter data given, smaller diameter data given. Means here data you have to find angle of the cutting tool, so that find angle of the diagram, so that path of the cutting tool will move angle wise to the axis of the workpiece. At that case, you can find the gradually increase diameter and gradually decrease the diameter. You can find the taper operations. See here. So how you find angle of or path of angle of a cutting tool? Formula that large diameter minus smaller diameter by 2 into L is equal to tan theta. So theta is equal to tan inverse. That means theta is equal to tan inverse large diameter minus small diameter by 2 into L. L means taper length. Here given taper length 15 mm. Smaller diameter given 19 mm, larger diameter 23 mm. By applying the value here, the angle value is, you can find 7.5 degree or 8 degree. To get more, it will get as a round of number 8 degree. That 8 degree will put in the machine, so that path of the cutting tool move angle wise to the axis of the workpiece. See here, this knot and this knot when loose, and this part means that 8 degree all set in the machine, and will put that 8 degree in the machine. See here, when lose this knot and this knot, I am going to lose this knot. And after losing, this part rotating in 360 degree. So here given instrument divisions 0 to 40 and 0 to 50. This is called compound rest part. And here is the datum line. This datum line consent to a division towards to right hand side, not left hand side. Now a division, after setting up a division consigned, then tied to both sides knot forcing. Okay, now setting over. Only this part, angle-wise, only this part will be rotated. Means cutting point will move angle-wise to the axis of the workpiece. Now we will to start. In 15 mm length, we have to do the taper operation. After on machine, I am applying depth, same process. Both cross slide wheel and carriage wheel constant. Only you have to rotate long slide wheel. That means path of the cutting tool will move angle-wise to the axis of the workpiece. That means one side diameter will be increased and another diameter will be decreased. And see here, the diameter gradually increasing, and this is called taper operation. Means produce a conical surface. Now over. Now
Any question?
No, sir.
Yes, sir.
Okay, then, so shall I go to the next slide?
हाँ सर,
Next video?
हाँ हाँ,
Yes.
ये सर टैपर टर्निंग इनको समझ में आया ना?
इसको तो क्वेश्चन नहीं है ना. They are not asking any question.
ओके.
If you want to discuss, then please you can.
हाँ, वही मैं बोल रहा हूँ कि जो टैपर टर्निंग स्टूडेंट कंपाउंड रेस्ट को कैसे हम लोग चेंज किए टू अप्रोप्रिएट एंगल, सो वो समझ में आया?
यस सर. सो वो जो सर दो स्क्रू थे सर, उनको मतलब लूज करने के बाद
हाँ,
वो
very
एंगल
good.
चेंज कर पा रहा था सर.
वेरी गुड. वो दो स्क्रू है जो कंपाउंड रेस्ट के बेस में, और दोनों स्क्रू को अगर मैं अनस्क्रू कर दूं तो वो क्या होगा, स्विवेल करेगा. दैट कैन
Yes, sir. It will rotate 360 degrees.
that will rotate. So when it rotate, we can adjust the position of that rectangular part or compound rest to our required angle. So how do you refer the angle is what? So there is on the base of the compound rest, so angular divisions are cut like 1 degree, 2 degree, 3 degree up to 20 degree, and opposite side again 1 to 20 degree. So at both sides we can change this position to 20 degree maximum. Okay. So to find the angle there, so there is a formula I told you. Suppose the initial diameter is given you the begin diameter. So the taper having two different diameter. So at the extreme end, one is let's say capital D or big end diameter, another is small d or small end diameter. Okay. So to find this angle, suppose let's say the taper angle I need there alpha by 2, let's say. Why I am telling alpha by 2? Because the included angle of the taper is alpha, and we consider we need half of that angle, because one part if I'll do, then the other part can be done diametrically. Okay. So suppose I need the taper included angle is 20 degree. So I need 10 degree. So that's why I here mentioned as alpha by 2 or theta by 2. So then tan inverse capital D or the big end diameter minus small diameter by 2 into L. So L refers to here the length of the taper. Okay. So the taper length may be there in the drawing. Without taper length we cannot imagine a taper. So the taper length into 2. So that angle we can find out in degree. Okay. And that angle we need to set at the compound rest by unscrewing these two screw there. Okay. Not there. So when you unscrew this, so that rectangular part or compound rest will rotate in its axis, and I can set to my angle, then I again screw that to bolt. So then I have to move the wheel which is attached. Strictly I have to move the wheel which is attached with the compound rest, not the longitudinal wheel, not the transverse wheel. Okay. Only the wheel which is attached to the compound rest that we have to rotate to move the cutting tool in a angular path. Okay. So curve path it cannot take, it will take one inclined path. I can say more appropriately, it will be inclined path. Okay. So that inclined path, the cutting tool will define while rotating the, it will move in that angle only. So which angle we set for the taper, so that angle, in that angle it will move inclinedly in an inclined manner, and we will get a taper shape by doing that. So because we are swiveling the compound rest, so the method itself is named as taper cutting by compound rest method, we can say, or by swiveling the compound rest method. Compound rest. Okay. Because compound rest is coming in here to picture for taper cutting. There are other methods are also there, like firming tool method and tailstock offsetting method. So these are not in our hearing with here our concern today. We will only discuss here about the compound rest method. Okay. And I got the point. Because we have to understand first the how to find out the taper angle. So that formula is I mentioned that, by that easily will get and you can do the taper cutting.
Yes, sir.
Okay.
Hello?
Yes, sir.
Sir, next video please.
Yes, sir. So this one is the last video.
Nulling operation this part over, taper operation over, this part also over, and here is the grooving operation. Grooving. Grooving means 5 mm length and diameter should be 16 mm and neck of the workpiece here or job. And this operation is going to start. You see, grooving, nulling operation, this tool completed and going to lose again. To maintain proper center height, the cutting tool with the axis of workpiece, you have to use the packing. Here is the grooving tool. This is made of high carbon steel. Here is the cutting point. You can observe this cutting tool. It was high speed steel and is used for facing operation and plant angle operation. And this operation for grooving operation, this tool used. This is called grooving tool. And for nulling operation, we are using the nulling tool. That means for different operation, different cutting tool you have to use. And going to start the grooving operation. This is the cutting point, and you have to set the cutting point to top side. And this side you have to hold the tool post. This cutting point should be proper center height. Yes. Then tied to cutting tool by help of tool post key. Tight closely, then set as a 90 degree to the axis of the workpiece. And we will do the grooving tool. In that place you have to mark just 5 mm end of our taper turning operation. Clearly marked. Now I am going to start. First on machine, then touch the cutting tool, then sliding here, then going to grooving operation, and creating a difficult and changing the packing because it is above center height of the cutting tool to the workpiece. It is not maintain exact center height, that's why one packing removed to maintain the proper center height. And creating the frictions and metal not removing properly. That's why getting the demerit here, difficulty. That's why again going to start. Now removing metal smoothly and cutting the metal by help of cutting point of the cutting tool smoothly and doing grooving operation. And moving the cutting tool to and fro motion in between length. Giving length. Cutting tool moving to and fro motions in between giving length. Now your grooving operation over. You are now experiment over. For this experiment, you have done 6 operations. First, lengthening operation, casing operation, chamfering operation, grooving operation, taper turning operation, and nulling operation. You can measure here, getting dimension, getting exactly yes, all are exactly getting. Then you can remove or you can lose your piece or job from the holding device. So, see here. This is your final. Okay, thanks.
So, student, so your online experiment is over for this particular shop, which is turning shop. So any doubt or any question?
Last operation was grooving operation. Okay. So grooving means, see, there also we are reducing the diameter, but in different way. A narrow passage or groove when you want to make. So this operation is required, and a separate cutting tool. We used there for cutting plane turning and facing, single point cutting tool or single point turning tool. But here the cutting tool is different. This is called grooving tool or parting up tool. Okay. So sometimes in engineering components we need many grooves to accommodate what o-ring or any packing or sealant to restrict the fluid of flow of any fluid. So there we need such arrangement groove. Okay, like I can give one typical example. Your pressure cooker, everybody know that. So pressure cooker upper cover, so that having a groove to accommodate one boring, so that the steam cannot come out to outside. Okay. So for this reason we need sometimes a groove, and here one separate cutting tool is required, that is called grooving tool or patting up tool, so that can be used for grooving operations. Okay, these are things only to remember here in grooving operations. So now it is understood to all this turning section or operation of lathe.
No, sir.
Shivam.
Yes, sir, understood.
Okay, thank you. Vinita Rajan,
Sir,
Yes, sir.
it is understood now?
Yes, sir.
Okay, thank you.
sir, we have to write this experiment that
You
we are
are,
turning.
sir will explain all these things, the procedure of writing, the record, everything.
So in the next class, we will you have to write a report, okay, on the turning shop. So I will give you the direction, okay,
Yes, sir.
during the class, and
Okay, sir.
I also will conduct a quiz online, okay. So prepare for the quiz. I think material has already been sent, right? Study material like PPT.
I think no, sir. You
No,
haven't.
sir.
Okay, then
No,
today.
sir.
Okay, then today I will send. Okay. Just
Yes,
told
sir.
them.
Sir, not by, sir, when the quiz will going to happen, sir, not next class, no, sir.
Yeah. By the next class,
Okay, sir.
not today's.
And when we have to submit, sir?
So on the day.
Sir, no, sir. About
During
the
the class.
experiment, you told no, we have to write
During
the
the class, you have to write a report, short report. Okay, don't worry. So like assignment 1.
Yes, sir.
Okay, you have to write a short report, right? Brief report. Okay.
Okay, sir.
So now let me take your attendance, sir. You
That
can.
means during the class we'll write the report.
Yes, yes, yes.
Sir, on the next class or this class?
No, no, on the next class.
Next class.
Okay, sir. Okay.
Sir, now we don't need to write anything now.
No, 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 no. This class is over.
Okay, sir.
Now let me take your attendance.
Yes, sir.
Okay. So once you have given your attendance, then you can leave.
Okay, sir.
Okay, sir.
So be careful. So today is 09.
Thank you, sir.
Welcome, welcome.